Hello guys, let's do this properly. Hello guys, and welcome to a video on first order differential equations. So, what is a differential equation to start off with? So, a differential equation is anything of the form dy of dx is equal to f of x and like a variable of x and y. Where this isn't a partial derivative, if you get confused by that. A partial derivative is where f of the function of x and y is equal to z. But we're only considering dy, we're only considering x variables and y variables for now. So we're going to start off with separating the variables. Separating the variables is relatively easy. It's not too bad once you get into the swing of things. So I'll show you just two examples, and then the rest of it you'll figure out. So the first example we're going to do. So find the general solution. Dy by dx equals x tan y. Okay, so here is a differential equation. So what we've got here is we have got 1x, find the general solution of 1 plus x squared dy by dx equals x tan y. That is our differential equation. This is actually fairly easy to do. So what you do here for separating the variables, as you have a dy and as you have a dx, what you do is you collect all of your x terms on one side, and then collecting your y variables on the other side. And that's why it's called separating the variables. You have two different variables. You take one variable, all one variables and constants on one side, and then the other variables or constants on the other side. So let's just do this quickly. So let's go through this example. So 1 plus x squared dy by dx equals x tan y. So what we're going to do here, what we're going to do is we are going to divide by 1 plus x squared and divide tan y and then times dx on this side. So this is what we're going to do. So dy by dx is equal to x tan y divided by 1 plus x squared. So what we're going to do now, since we've collected 1 plus x squared on this side now, what we're going to do is we are going to divide tan y to bring it onto this side, so it becomes 1 over tan y, which is going to become cot y. And now we're going to times dx onto this side. So you have all your x terms on one side and all your y terms this side. Just let me show you for 1 second. So 1 over tan y dy is equal to x 1 plus x squared dx. Now do you see? Do you see now that I've collected all my y variables on one side and all my x variables on the other side? Now do you see that? Okay, good. So now what we're going to do, we're going to integrate both sides with whatever respect we're doing to. So on this side we're integrating with respect to x, and on this side we're going to be integrating with respect to y. So what we're going to do is the integration of cot y with respect to dy, integrating x over 1 plus x squared, which I think is looks like an arctan, but oh no, sorry, it's a first guess, second guess. Dx. So what we're going to have on this side is what was it? Ln sine y. Ln sine y is equal to first guess, second guess. So when you differentiate x1 plus x squared, you get 2x, which is very close, so it's going to be half x. So that's going to be half ln 1 plus x squared plus, we're going to add ln c. Ln c is just our constant here. That's all it is for now. Okay, so what we're going to do now, we are going to times these together. So what we're going to do is, oh sorry, I forgot to mention as well, we're going to take this power up here. So what we're going to get is ln sine y equal to ln, we're still going to continue calling this c. So the power of logs is that if you have ln a constant plus ln a constant, it just becomes ln, and you times those two constants together. So what we're going to do, this is now ln 1 plus x to the power, 1 plus x squared all to the power of a half, square root of 1 plus x squared. You should recognize that, definitely. So now, what we're going to do is, we're going to eliminate lns on both sides, so we end up with sine y is equal to is equal to c 1 plus x squared. And we're just going to leave it like that. This is our general solution, because otherwise it will just be too complicated. You know, y equals arc sine c. It's just hideous, and there's no point doing so. This is the general solution. Usually most exam questions, or rather all exam questions that will have differential equations, will say find the general solution to this. And then you'll have to answer a part B question where it says, with these boundaries where y equals 0, x equals 0, or dy by dx equals a half, or something like that. And then you've got to find your constants. You find your constants, and then you find the particular solution. Because with the general solution, you keep your constants in. In a particular solution, you don't. And therefore, you keep your constants in when you find the general solution of this differential equation. So, we're going to just move on to another one. So, another separating the variable. Okay, so what we're going to do is find the general solution of, let's see what we're going to do, of the differential equation dy by dx equals minus y over x. That's what we're going to do. So dy by dx is equal to minus y over x. So what we're going to do, we're pretty much going to be doing pretty much exactly the same thing as last time. We're going to be separating the variables. So you take all your x's, so you take all your x variables on one side and all your y's on the other. Preferably take this y, let me start again. So what we're going to do is we're going to take our x variables on one side and take our y variables on the other. So if we divide y and times by dx, we are going to end up with dy over y equals, so times in dx, minus dx over x. You can put, it doesn't matter what you put, but you can put 1 over y dy or 1 over x by dx, but it doesn't really matter. It means exactly the same thing. So what we're going to do, we're going to integrate both sides. So we're going to end up with dy over y, It's essentially 1 over y with respect to dy, but we're just going to put dy for simplicity. Equals the minus. We're factoring that minus out because we don't need it. Dx over x. Sorry, all 1 over x with respect to dx. Doesn't matter. So when we integrate 1 over y, we're going to end up with ln y. You can put the modulus signs. It just means it's greater than 1. It will always be greater than 0. It just deals with a whole load of errors, because as soon as you set ln 0 to... when you put in ln 0, it's going to tend to infinity. That's what's going to happen. That's why it comes up with an error all the time. So let me just get on with this. So when you integrate 1 over y, you're going to get ln y. When you integrate 1 over x, you're going to get ln x. With the mod signs, of course. And we're going to add a constant as well. So we're going to call this ln a. Preferably, I prefer to call it a because this is an arbitrary constant. An arbitrary constant means the constant value can be pretty much anything. It doesn't really matter because this is a general solution. So what we're going to do, we're going to take x on both sides. Sorry, we'll rearrange it for x to go on that side. Sorry, you'll see what I do. So ln y plus ln x is equal to we're going to actually call it ln c, but we're going to call it we're going to keep ln c for now. When you obviously laws of logarithms, so it's going to be ln xy equals ln c. And now what we're going to do, we're just going to get rid of the ln signs, or basically everything, if you know what I mean. So we're going to call this a for now. And now y is equal to plus or minus a over x. The reason for the plus or minus, I was meant to put modulus signs there, but it doesn't particularly matter, if I'm being honest. As long as you recognize that this is a plus or minus, then it should be fine. Now, the reason it's called a general solution, if I draw the graph of plus or minus a at x, where a is an arbitrary constant, so a could be any value between anything greater than 0, basically, and not including 0. So if I can call that y-axis and x-axis. So this is what it's called a family of solutions. A family of solutions essentially means when you have an arbitrary constant greater than 0, it can be essentially anything. So it can be like that, or that, or that. So it's like that. So you can have many different solutions. Just remember that each corresponds. It doesn't really matter, but you're not going to get asked to draw a family of solutions. The only reason I'm showing this is why it's called a general solution, because when you have an arbitrary constant, it can be any one of these. It can be 3 over x, 5 over x, minus 7 over x, minus 9 over x. Doesn't matter. It'll be an arbitrary constant for a reason. So now we've essentially finished separating the variables. It's not hard. It really isn't. So what I'm going to do, I'm going to set you some exercises and see how you do.